So one of the prominent uses of deep learning or artificial neural networks is in the domain of IT, and actually it made a business case for them, right? Marketing analytics, feature recognition, and some of the applications I will talk, they have actually revolutionized the our life. It has changed our lives in certain ways also, and fundamentally these are the techniques or applications that has helped us bring the popularity of the deep neural network. So let's start with the first one, which is like Facebook deep face. In fact, I want to start with a caveat that they have removed the deep face feature in 2021 after like a sort of uproar by people across whole world, because people do not want to be tagged and be stored in the database, and they do not want their features, their face to be recognized easily. So this was something that they included in their feature list, I think around 2014 or 2016, I'm not sure on that date, but at that point of time they had this feature in the Facebook which basically helps them to tag a friend. So it will automatically recognize and label a friend. You just need to tag some people, and that will help us in identifying who are in that picture. So this application is this deep Facebook application. Let's see what is involved in this. Okay? So this is a facial recognition system, and what it does is identifies the human faces in the digital images. Okay? And in order to train this, actually this is published as a research paper by people belonging to Facebook research group, and they use this as a preliminary thing that they published. But I think when they actually implemented this system, they trained that system with way more than 4 million Facebook images, right? That essentially is the pipeline that allowed them to increase the accuracy of the face detection. And when they reported this, right, this paper reported that it was 97% accurate in the, in terms of feature recognition. And 97% accuracy is some sort very close to human level of accuracy. That's what we are able to recognize, in terms of faces and all. Okay? And as I said, this was developed by Facebook AI. So let's look into what are the main components of this algorithm. So this one was composed of 4 different stages. First was detecting the face in the image. The second was aligning the face detection. So this is a face alignment algorithm which comes from computer vision domain. And then representing the facial images through a large deep neural network. So this is what you are learning maybe today in the class is essentially the feature recognition and representation was essentially carried out using the deep neural networks in that framework. Okay? And then they classify the image comparing a feature vector. So let's go through not all, but some of this computational steps. Okay? So if you see this deep face, this identifies human faces in a digital image. So what they do is first they apply this face cropping. So given an image, there are techniques in computer vision which are different than machine learning techniques, which helps you in given an image, it will basically crop that image where the face is located. So that's what you need to first do. In an image, you need to crop. And now you can see that even in a given image, the faces could be aligned in different way. For example, this face, if you rotate it slightly, then you get this face. If you rotate that in this face, you get this image, right? And this is the issue that in an image, you might have the face aligned in different orientation. So in order for you to do proper representation, what you need to do is you need to counter those rotations, and this is known as image alignment. That is a step that is typically coming from computer vision, which might not be your domain, but people who are in computer vision, for them this is a basic trick that they can take image and they can align those images. So that's the alignment space that is there. And once you have done the alignment, you will have this, which essentially becomes an input to a deep neural network. Okay, so in this, once the alignment is done, that image becomes an input, and RGB of and red-green values of each of the pixel becomes the input features that goes inside, and then you have this different convolutional neural networks, which we'll talk about probably next week. And then towards the end of it, you have this is L4, L5, L6, which are the classical deep neural networks that allows you to take the image on the left hand side and create a representation. Okay? And once you create this representation, we'll see how you can use that to do the face identification. So again, this was a complex neural network where first 3 layers, C, M2 are convolutional networks, whereas L4, L5, L6 are essentially the deep neural networks that we talked about in today's. So once the representation is done, what is done is like, you will take 2 images, and using the deep neural network, you will output not a label, but what is known as the face descriptor vector. So given 2 different images, once you pass that on through a deep neural network, it will give you essentially a vector. These 2 images will give you 2 different vectors, and you can essentially compute what is known as a cosine angle or weighted distance between those 2 vectors, and that will allow you to compute the similarity between 2 images. And if this similarity is high, right, let's say more than 0.9, right, and so on, then you can tag the new image based upon the tag that has been associated with the old image. So if I bring in this one and compute the similarity of this image with this one, we should get a high similarity, and if the similarity score is high, then whatever is the label of this one should be allocated as a label of this one, and that is what is the overall algorithm that is there inside the Facebook deep face at a high level. But the most important part is getting this descriptor feature, which allows you to compute very precise similarity score, and this deep face descriptor is essentially enabled by the combination of convolutional neural networks and the deep neural network pipeline. And again, as I already mentioned at the beginning, that the accuracy of this class of algorithms are very, very high. For 4 million images, 97, I am pretty sure that after that, they trained the overall networks with even more number of images. So the accuracy of the detection was probably even way higher than 97% when they actually fielded that application inside the Facebook. Having said that, there was a huge uproar when people were not happy with the fact that Facebook is, doing something like this. And because of that protest, I think, gradually last 2-3 years and towards the end of 2021, this feature is no longer inside the Facebook that is there. But having also said that, they have not promised that whatever the training or the data that they have collected, they will not use it in any new future applications and so on. So they have this technology and they have this huge database of images. Those are the 2 powerful things that they have, that hopefully they will find some application to monetize later on. Okay.